it flies. Yeah, a little bit of pollution, I agree, which is kind of where I come from to try and teach about that. But everything that's powering that through the air was once water. I'm talking the kerosene fuel, JP5, jet fuel. That it was once water. We all know that. The water is turned into organic materials. The organic materials get laid down by mass extinction. That mass extinction then forms coal deposits. Underneath every coal deposit you find the mine dollars, which used to be urchins, sea urchins. So it was an inland sea at one time that we now see as a coal seam, a coal deposit. The ooze that is cooked out of that by a conflagrating atmosphere is then filtered down through the runoff that comes from the rains that follow the mass extinction that cause these huge floods. The best example where you see this in process is the Gulf of Mexico, where layer by layer you find very common things. The older is on the bottom, of course. Then the coals are up mountain, I guess you would say, up elevation, in valleys and areas that were existing at that time. The coal is charred woods. Then the ooze that is cooked out of that by this mass conflagration of the atmosphere is then washed out to sea. It drains salt water, settles down, and then the great floods that follow mass extinctions cover it with sandstone, or capstone as it's called in the drilling industry in oil. That capstone is what then holds it all in, keeps it down, where we can then penetrate that capstone, get into those old deposits and use them as what we call the petroleum industry today, or crude oil as we know it today. But if you look at the different places moving out from the continental shelf in the Gulf of Mexico, you will notice that you will find that you'll penetrate 5 mass extinction events right down to the bottom layer, which is usually the better oils. The newer the oil layer, the more junky the oil is. So like Saudi Arabia has very thick, ugly, hard to refine crude oil. You go to an ancient area like Indonesia, and you can almost take that oil, put it into your crankcase and use it as it comes out of the ground. It's nearly that pure. So everything that we use to get around once was organic material. We know that. There are sediments that produced in the near shore from algae that grow in plankton that grow in the ocean that also form oil deposits. But for the most part, they're all around the margins of the continent, and they all wash off the margins of the continent. But what needed to make this tree in the first place? Where did oil get started? Certainly this organic material. Right out there. Water. When they say, oh, water can't burn, I said, yes it does. It goes from there to the tree to a mass extinction event, falls down, becomes coal. The saps and other things, the ooze come out of that is being cooked off by natural processes of this extinction event, washed into the ocean, sinks to the bottom. Floods follow because of the particulates in the air that droplets need to form on. Plus, this tree right now is full of water. So you burn this tree, you're putting suspended water directly back into the air, not just through the production of hydrogen and oxygen in the form of water. Hydrates in the tree, oxygen in the air combine to form water. Now that's a scary thing for the earth to a certain degree, because of the fact that everything we burn that once was a tree goes back to water, just like my hydroxy. Okay? Only the hydroxy cuts out about 3.5 million years of time. So we don't have to go through that step. We just take water, make fire, then back to water. This does the same thing. Water to combustible material, to fire, the jet engine, and the jet fuels, back to water again. But the problem is that everything that this tree cleaned from the air, like they say the lungs of the earth, I don't say that. I call it the filters of the earth. In those ancient atmospheres were toxins and arsenics and poisons like we wouldn't believe. You think of the Earth at its early times. It was volcanoes and noxious gases and sulfurs in the air so thick that it would kill us today. So we weren't ready. The Earth was not ready for life. But when life started, the stromatolites, if you study about them, they're amazing. They take all that toxin and they turned it into oxygen. Once there was oxygen, then oxygen-dependent life forms, which we are, could come into being. But these earlier life forms had to be to make the oxygen. Stromatolites, the trees, the vegetation, everything else. There, once again, everything works in a way. But we're taking 5 mass extinctions and throwing it back up into the air with over 150 years. Not a good plan. But you say, water can't burn. Yes, it can. Right there, to coal, to oil, to our extraction, that from the earth where it had been sequestered away, all those poisons that were done in that. Is there a natural order to that? I think so. I think so. Somebody or something, some entity knew more than we did. Oh, it just happened naturally? Oh, okay. That's what you think, that's fine. I don't care. I say it had a purpose to it. Other people say it didn't. I don't care. The reason being, it's the same thing. Water, to carbon material, to our fuels that we use, to the pollutions being released, to the energy that makes our world turn. But when you can skip about 5 billion years, let's do so. Because it's water, to fuel, to water, without ever touching carbons and the pollutants and other things. And we can make our steels, warm our homes, do whatever we need. So don't tell me water can't burn. It does. I just proved it to you. Right there, to coal, to oil, and then back, what? To water. The exhaust of that, like I said, my grandma's tea kettle experiment. Fire packed with ice and water inside the tea kettle to form a cold surface. You can watch the water come directly back out of fire. So I hope this helps bring that a little bit clearer, how that relationship works and why stumbling on it, being a stubborn child, well, water should burn. I came up with hydroxy and the making of steels, a high school project. Okay? Did that work it all together?
Yeah.
Okay, and we had that jet come over too, right at the right time.